What's up YouTube? Going to be showing how you can get the full model of DeepSeek R1 running on your device locally. Not very practical, but might still be interesting for those who want to try it out. I have this 64GB RAM laptop that I'm going to be running it on. It also has 8GB of VRAM with an Ada 3000. But since it's such a big model, we really only care about RAM. So, on the screen right now, you see this blog by Unsloth. This is the tutorial I followed, and at the end of it, we were able to do a generation inside of the terminal here in VS Code, and then play a little Flappy Bird game. So here we've got Flappy Bird going. It works pretty well. Hit the block, and we end the game there. So going to be going over how you can get this on your computer if you want to get it set up, and then also some other more practical, versions of it, like the smaller distilled models we can run locally as well. I use anything LLM to get them up and running. It's just a very easy way to use these models. I like anything LLM. You got a bunch out there. You can use Uba Booga, Olama, and then I'll talk a little bit how you can also use some services on the cloud to get this up and running as well. So yeah, let's get into how you can run the full model locally. And so we're going to need a few things on our computer. The first thing you need is Visual Studio 2022 build tools with C++. So you can just go to this page here, go to community, free download, and then get this up and installed. And then we're going to need the CUDA toolkit 12.4 as well. So Windows 8 x86 64, Windows 11 exe locally. So I got those installed here. When you run Visual Studio Code, you'll get something like this. And then in here, you want Visual Studio Community 2022. And then when we install it, the important things we want are this desktop development with C++. So select that and then make sure the following here are checked. So MSVC v143 here, you want this x64 build tools, and then make sure this Windows 11 SDK is also going to be installed. And then just make sure these other ones are checked as well. And then you can start to download it. So it's going to be about 10 gigs to get installed. And then you want to get CUDA Toolkit 12.4. Now, yes. And then you're just going to go through the installation instructions here. Just follow all of the prompts and you'll get this installed too. Now, this is only needed if you want to offload a little bit of computation to the to your GPU, which I am. And then we are going to build Llama CPP, which is what we're going to be using to run this model locally. So once you have those two things installed on your computer, we can go and follow these instructions here. Oh, and there's also one more thing you want. You want Git installed on your computer. So download Windows, click here to download. And then this exe, just follow all of the prompts in there. All the default values are fine. And you should have everything you need. So Git, CUDA Toolkit, and then Visual Studio 2022. And then we are going to build Llama CPP. So to do this, we want to clone it onto our device. And so we can go to our file explorer. Let's just type in CMD. That's going to open up a command line prompt here. And then we're going to clone the repository, paste that. And then we'll change directory into there. And if you don't have an NVIDIA GPU, you can run these two commands for the CPU build. It means that the model won't use your GPU at all. But for my build, I'm going to be using CUDA. And so we can scroll down here. And these are the commands that we want to build it with. So we don't want to build it in this window. We actually want to do it inside of x64 native tools command prompt for VS 2022. And if you don't see this, that means your Visual Studio 2022 didn't install the build tools correctly. So make sure you have those installed. And so when you search x64, it should pop up, and we're going to run it as an administrator. So yes, open that up. And then we are going to now navigate to wherever we clone the repository to. So what you can do is just double click into the, let's go back. You could just right click and then do copy as path inside of Windows 11. And that'll be a way that you can find the path to it. But we'll just do change directory twice, double dot, to get to our root directory or our C drive. And then we'll just do change directory. We'll paste that into here. and then that'll put us into the folder. So if we type in dir, we can see that we've got all of the files from the git clone that we did earlier, and we should be good to go. So type in cls, we'll clear that, and now we can just start building the package. So make sure we are in x64, throw that in there, so paste and then enter. And so it's going to start setting up the environment to be able to build the package. Alrighty, and so we don't have any errors here, so that is good. If you run into any errors, well, make sure you have the CUDA toolkit installed correctly and then build tools, but it can be quite a bit of troubleshooting if you run into errors here. So the biggest thing would be if one of those things weren't installed on your computer, and you try to get this up and going. Also, if for whatever reason the build is messed up and you need to restart from scratch, just delete the llama.cc. Just go into llama.cpp and then just delete the build folder, and then you can try to start building again from scratch in case anything was messed up from maybe like a botched install. But once that line is finished, we can now proceed to the next one and then just paste that into here and it'll start to build it. And this is going to take a little bit of time. So I am going to cancel the build because I already have one that was built here. So here we go. Everything was finished up in this command prompt. And then after that, you can find llama cpp inside of your build folder. So I'm going to navigate into an environment where it finished up. And so I have that llama.cpp folder here. If you go into it, go into build bin release, you should see a llama-cli.exe file. And if that is in here, then we are good to go. So with that, I am going to now open up this folder inside of VS Code. So right click open with code, and that's going to bring me into my VS Code environment. Really recommend that you have something like VS Code on your computer. Just makes things a little bit easier for these programs, and I just like how it's organized. All right, so now we're going to go into this Unsloth blog, and we're just going to follow a few of the instructions here to get the model downloaded and running. So scroll down to this area right here, and we want to copy and paste this inside of a Python script. Now, I realize I never showed that you should also be downloading Python as well. So you can go to the Python release page here, go to the Windows 64-bit installer, and then just run through all of the default options in here to get it installed. And make sure that you checkbox the add to path. It should be on the first window that pops up on the installer so that you can access Python from the terminal. And then if you have Python installed on your computer correctly, you should be able to do Python in any terminal and it should pop up. If not, just close out of all of your terminals and then reopen them back up and you should have it. Sometimes VS Code is a little bit weird with it. So if for whatever reason your environment isn't updating inside of VS Code, close out of it, go to whatever folder you want, type in CMD in the address bar, type in code and then dot, and that'll refresh your environment variables inside of VS Code. So back to Unsloth now. So just copy and paste this code block into a Python file. So in this case, we've got one right here. Just paste it into the file. And then we want to uncomment this area right here. So control / or you can just delete the hashtags here. And then we want to install these libraries so that we can start using the Hugging Face download feature. So we're going to create a virtual environment for that. To do that, I would do pi space -3.11 venv. So that's going to create a virtual environment. I have one created already. And then now I just do venv scripts and then ACT tab. So I'm using tab to autofill that. But once you do that, you should be able to activate it. You'll see a green little venv here on the left side. And then we can start installing Python packages into this virtual environment. So we would do pip install Hugging Face and then Hugging Face transfer. And I already have these installed, so it's not going to install. So I'm going to clear out my terminal there. And then what you can do is just run this by doing start debugging. And what it's going to do is it's going to start downloading DeepSeek to a local folder. So I already have mine downloaded, so it's not going to do anything. And once that's done, you'll have these folders with these 3 massive giga files inside of the folder, and it's going to be about 130 gigabytes. So you're going to need some space on your computer. And if we navigate into the folder, first one is 48 gigs. Second one is 48 gigs, and then the third one is 40 gigs. So pretty hefty, but we can run them as long as we have some CPU RAM. And then now we can start trying to use this. So alrighty, now I realize it might have been a little bit unclear because I moved over to a different folder to start doing the DeepSeek R1 download. So let's say that you get cloned and you finished building llama.cpp. What we can do is we can just copy this folder into whatever project folder that we downloaded DeepSeek R1 into, and then we can just paste it into there. So we're going to do that right now with the llama CPP. This one has the build that's finished. And then now we can use it. So once DeepSeek R1 has finished downloading, we're going to call directly into llama.cpp in order to use this. So we can start building the command line prompt here. So we can type in llama. It should be .cpp. Then we're going to type in build tab bin tab release tab llama, well, it's llama dash cli.exe. So this is going to be the command that we call. So just clicked in enter there just to make sure that it is running. And so it is, which is nice. And then we can just start to build the command prompt here. And so we can just go like this and then start doing a little bit of copy and pasting. So let's go to double dash model, paste that into here, do space, double dash the cache, paste that into here, threads 16. I'm going to change that to threads 12, prio 2, and I'm putting a space between it. So make sure you do a space. So space temp, space context size, space seed, ngpu layers, space ngpu layers. We're going to do 2 because I've got a very tiny GPU, and then no conversation. And then we'll copy the prompt here to make a Flappy Bird game. So there we go. We have that all built into the terminal. And then we're going to click enter. So this is going to take a little bit of time to do. And I am not going to let this finish because it's basically going to kill my recording, as it's going to take all of my CPU power and then all of my RAM. So this will just take a very, very long time to do. On my computer, it took me almost 3 or 2.5 or 3 hours to finish one generation. Here we have the amount of time it took. When I did the calculation, this came out to about 7 hours, but I think that's because my computer died and then I had to recharge it and continue, which is, I think, what made it take 7 hours to finish. But yeah, you can try this out, see how long it takes for your device. But it does, it does work. And this is the output that it came out with. Now, it did have kind of an issue. I actually had to manually add this screen variable into here. So it just gave me these uninstantiated variables in the code. So this would fail if I tried to run it. But, I didn't want to rerun it on a different seed to try a different result because it took so long. So I just added it manually myself. And then so when we run this, we now have that Flappy Bird game that we saw from a little bit earlier. So there we go. And it works. So yeah, this is pretty neat. Game over, score 6, and it closes. So that does work. So there you go. If you want to get the full model running locally on your device, you can get it installed like this. You just need to build llama CPP and call it via the command line interface. Now, there are probably a few different ways you could do it nowadays. You could use, I think you should probably be able to use abbott-lens, Python, Llama CPP, GitHub branch. Here we go, abbott-len. This is his Python CPP branch of Llama CPP. But I didn't try it on here. I just built it from the source to just follow this Unsloth tutorial. So that is how you can get it running on your device locally. Now, if you run into any issues, I'm probably not going to be of much use in the comment sections because there's a lot of different things that could be going on here. But this is kind of a overview on what you need to do. You need to build Llama CPP and then download the big model, and then you can run it. So with that, you can get the full model running on your device locally. Now, going to be jumping into the sponsored section of the video. NVIDIA let me know that they are also releasing a NIM with DeepSeek R1. So just want to cover that option if you want to have an API that you can call to be able to use in your applications. So I've gone over NVIDIA NIM in several other videos, but it's a microservice that you can use and call via API to use their GPUs to run their containers for these open source models. So in this case, they have built a DeepSeek R1 one. So currently right now it's a hosted API, so NVIDIA hosts it. They do plan on releasing a self-hosted API. That is one that you can run locally if you have the GPU power to run it, but they are still building that. But as for their hosted API, I'll show you how you can use that. So if you sign up with an account, you get some trial credits that you can try out with. So I have one right here. I've got 1,000 credits left, and we are just going to make some API calls over into DeepSeek R1 from NVIDIA here. So we can copy the code right here that they give to us, go into VS Code or any IDE, create a new file. Let's just call this, I'm just going to call this nim deepseek.py. And then here we are. So we can paste that into here. And to do this, and then now I'm going to activate my virtual environment and then pip install OpenAI so that we can make a request to over into NVIDIA following this format. And then we just need an API key. So we can get an API key here. Going to generate a key, and we can put our API key here. I put it into a YAML file so that you guys can't see it, but in here you would just put in whatever printed out, whatever long serial number that you had there for your API key, or API key, not serial number. And then you can just run this. So we are going to do F5, debug, run this. And then there we go. Once I fix that to safe load, it is outputting into the terminal here. And there we go. 9.8 is larger than 9.11 there. And we can use whatever message we want inside of here. I could probably even ask the same thing for creating a Flappy Bird game. So let's just try that out real quick. Go into here. I'll paste this into there. So role, which is user, and then content. If you just want to make it a text that you can change you can change outside of the parameters you're passing here. This just makes it a little bit cleaner on what you're putting in. We can just now run that, and now it's going to create a Flappy Bird game. So I think it hung up here because I think it hit max tokens at 4096. So we could just change that amount to something a little bit higher and then re-inference off of that. So we could do like 8192. Alrighty, so it finished up here. So we can just take all of the code it created, copy that, paste it here, and then we'll run that. So Python debugger, and here we go. We've got the game here. Now this one is I'd say it came out a little bit better, but the ball is falling kind of slow. This is kind of impossible to actually probably play, but we can do a reiteration on that. But this is our Flappy Bird game. So that is very cool. You can use NVIDIA NIM to get that accomplished if you need it via API. And then one more thing from NVIDIA, their annual GTC is coming up on March 17th. So if you want to attend the conference, you can attend in person or you can do it virtually as well. This is where all of these cool new tech things that NVIDIA is working on and what's in industry are going to be talked about and discussed. So lots of cool different sessions that'll be going on here. You can go over their catalog, what types of in-person sessions they have, what virtual sessions they have here. So if any of this interests you, head over into the GTC session catalog and take a look. I wish I was attending in person because they have some cool stuff like robotics that they're going to be talking about. And it seems like they're making a real big push towards AI in robotics. And I've always found that stuff kind of fascinating. So things like this will be in person. And they've got a bunch of different things they're going to be talking about here. So yeah, you can buy tickets to attend this conference in person, or you can attend this virtually on some of the sessions that they offer online. And then of course, one thing that goes without saying, you can just use DeepSeek from their online chat as well if you want, something that's different from ChatGPT. So here you go. You can access DeepSeek R1 and V3 from just DeepSeek, from just chat.deepseek.com. And then real quick, let's just cover how you can run it locally in a more practical way. So I'm going to be showing the distilled models. For this, I'm using Anything LLM. I think it's neat. So you can just download for desktop, download for Windows x64, and then once you go through that, it'll start downloading the installer, go through all the default options and get it installed onto your computer. And then when it launches, this is kind of how it'll look when it's launching. You'll be met with this homepage here. So let's go and start downloading some of these models. So I have a little bit of an older version. I don't think it's been updated to have DeepSeek models listed locally, but I'm going to show how you can get these models from Ollama anyway. So it doesn't really matter too much. We're going to go into that wrench here, open settings, LLM, and we're going to choose Anything LLM here, and then import model from Ollama or Hugging Face. So we're going to click on that, and then we're just going to navigate into Ollama's DeepSeek area. And you can find all of these different models here, depending on your GPU. You can download and try these models based on these VRAM requirements on this right side here. So I'm going to use the 8B one. I can technically run 14B, 32B, and even the 70B as long as it fits onto my RAM. But anything that's above 8B on this laptop is too slow for me to actually want to use. So I'm going to download this 8B, and then we just click on this copy button here, navigate into Anything LLM, paste that into here, and then import it. Now, I already have it here, so I'm not going to do that, but you'll import it, and then you'll start seeing it download in this top right corner. And then once that finishes up, you can now use it. So we'll just create a new workspace here. Let's just call this test. And then we'll go into this cog for the settings, chat settings, system default. Let's change this to Anything LLM. And then we'll just change the model that we want to run. So in this case, we're going to do DeepSeek R18B, and then scroll down to update workspace. Going to update that, scroll back up, click on this back arrow, and then that'll put us into the chat. So that is really nice. So we can just ask it something like, "Hey there, what's up?" Send that in there. It's going to start loading the models, and you can see now my GPU has 6.6 gigabytes of VRAM being used, and it's running through the generation there. So there we are. You've got your unique little think tokens at the beginning and end, and then the output here. So yeah, DeepSeek R1 running locally is very neat. Like I said, the only one that's really useful for me though is like the 32B one, because for some of these use cases that I want to try to do, such as like separating sentences between different speakers for like my audiobook maker, requires a little bit of a smarter model. Even 32B gets it wrong every so often. And then I also use it for different Whisper applications. And yeah, so that's going to be it. I'm still currently playing around with DeepSeek R1 to see how useful it is for some of my applications. And it is nice that we get a powerful model that we can run locally like this, that we don't need to really fine tune to be too useful. So yeah, so far, what do you guys think about DeepSeek R1? Are you guys using it at all? Any cool use cases that you guys have found for DeepSeek R1? Always interested in hearing what you guys are using it for. But yeah, it's been a little bit of time since my previous video. I was out of town last weekend. The next video I'm going to be making is about Zonos. I think it's a cool new TTS system that has been released, and it sounds really good as zero-shot cloning. So once again, I'd like to thank all of the members of the channel for supporting me, and I'll see you guys later.